Hello and welcome back. In this new video, we are going to build on top of the what we discussed previously. Uh, in our previous video, we created this Postgres database and ran it in a container. Uh, then we used the built-in uh, IntelliJ database client to actually create a database, employee DB, and create a table and insert some data and retrieve them via the provided console. Now, what we are going to do is that we are going to retrieve this data actually at runtime. So the way to do that is that there are multiple ways of doing this. Multiple organizations do different things. Some they use JDBC and they write the queries and they retrieve the data, and that's totally fine. Especially if they have this approach of bottom up to bottom. So what that means is that they already have the database set up, and then they create the code to interact with that database, um, which actually is not a bad idea. But um, um, if you don't have the database and we are starting from the scratch, we can um, do something like more professional and more techy. What we can do is that we can create our POJOs that represent our database tables. And we are going to, because this is a simple applications, we are going to go that way. How does that help us? That helps us to utilize Hibernate in a very simple way. One-to-one mapping between the tables and our POJOs, the column names, and our class property names will match. So to do that, right now, this employee that we have defined here, it doesn't have employee ID in it, but in the table we do. So and the norm is to put this employee, if you want to use it as an entity, into an entity package, but right now it's in a model package. So let's start this with refactoring this name and changing it to entity. Names are powerful. They tell us about a lot about an application. When we use entity over here, we understand that now we are dealing with JPA mostly. And then we come and change this POJO to become actually an entity. How do we do that? We annotate it with entity annotation. However, for this to be available, we have to make a change to our POM file. And I have already made that available to us. We need to use a Spring Boot Starter Data JPA. This provides us with the JPA and Hibernate and the JPA annotations. And we also need over here to have the driver for Postgres so that our applications can talk to the Postgres that is running. Once we do that, we have these annotations available to us, such as entity, for example. And we are getting right away that error because when we create an entity, we need to define an ID, like so. And so should have okay, it's complaining that we don't have also a no-arc constructor. We can simply create that here. And let's do that manually. Uh, so this is basically a no-arc constructor. So the error goes away. Now, as I explained, we have an employee ID over here. So let's add that private string employee ID. And we need getters and setters for this, right? So let's generate them. both getters and setters. Actually, yeah, for the ID, we should already have them, but looks like somehow it was removed. Anyhow, so now I'm going to rearrange this to make this look a little more neat. And then what we're gonna do over here, we know that this ID was big int, right? So we're gonna change this from ID, from string to long, okay? And once we do that, we have to fix these errors, okay? This should do. Okay, now what does this employee uh, entity maps to? It maps to a table called employee. So the table name is in employee. All right, with the lower e. Okay, we don't want to create issues down the road. So now if you look over here, this first name column is first underscore name. But over here we have the first name like so. So we have to, there is a way to do this. We can specify a column and say the name, this maps to a column that has this name, first underscore name. And this one maps to a column that's name is like so, right? Very well. So far so good. I think this should do it. Now we have an entity, and congratulations, this is our first entity. So we go to the service class, and in the service class we see that everything is hard-coded, but we want to retrieve the data dynamically using this. And I can see that there is an error somewhere down here. I want to find out what that error is. Yes, we changed this to long. And we also added an employee ID, if you remember. So we can say for the for this to work, we can add that employee ID right there and put it here as well, just to finish the mapping correctly. And what is the issue with this one then? Oh yeah, well, this needs an employee ID, but we are not going to do that now because we are using our approach over here for the service, and I explain to you that soon. To retrieve the data from the database using JPA, we need to create a, repository. So we create a package name repository. It could be also DAO, but names, as I told you, are expressive. So when you use repository, an entity, then you know you are dealing with Java. But usually when you are using model and DAO as the package name, it means you are using with JDBC. So you're writing your queries yourself mostly. So anyhow, this is a repository and we have an employee repository in it. Okay, an employee repository is a repository. Very well. And over here, this is not actually a class. I apologize. This should be an interface. Okay, and this interface should extend another interface called a JPA repository. This JPA repository has two types. One of them is the employee, which is the entity, and the other one is the data type of its identifier or primary key, basically. Once we do this, this repository automatically creates, can basically generates um, using the backend data. Basically, it can do automatic configuration to return uh, employee records for us based on ID. It could return a list of them by using find all, or it could return an um, individual employee by using find by ID, for example. I demonstrate that soon. Uh, we seem to be good with this repository. As you can see, I am not using any JDBC code in this repository for the fact that I'm not even using any method. The methods are already available in JPA repository, and there is a whole bunch of them. If I go to them, and you will see all of these methods are available. Get by ID, for example, is find all, and and a whole bunch of other methods, such as saving. Uh, but let's come back to this later. And so in the service class, we are going to summon this repository that we just created. Mm, right there. If you can click, don't type. That's my motto. Okay. So over there, and then over here, we can say, okay, employee emp equals, and then we say repo dot find by ID, and we pass in, let's call this ID. I'm going to correct that. And this was actually a long, if you remember. So if you're following, we are using that as a long. Okay. We are saying that we are getting this error that this is an optional, but we are returning an employee. So uh, this method, find by ID, returns an optional. And the way to specify that now, the correct way of this is optional, and we specify the type that this optional may contain. So we import that class. Now we can't return this optional. We need to return an employee. How do we do that? We say, okay, let's do this. Employee optional, and this employee optional, um, if it is present, basically, that means if it has a value, we can get and return it. How do we do that? Or there are other methods over here available to us, or else, for example, to return a different result if nothing is returned by calling find by ID. There is also another uh, method available for us, or else throw. We can throw an error message uh, if the object is not available from the database. So oh, it all depends on how we want to handle this. But let's do something. Let's because we want to demonstrate the error handling, let's code this in a way that down the road, if we pass in an ID that does not exist, it throws an error. And then in another future episode, I show how to handle that error. But for now, let's keep it simple. We say if present, so we wrap this in an if statement. Uh, all right, then we say return employee optional dot get. This will return or I'm sorry, let's see what was the issue over here. If is empty, okay. If it is empty, or if it is present, if is present, okay. I'm not sure why I got that error, but beats me. Anyway, if it is present, we get that object within the optional and send it back. But if it is not present, let's return um, null. How about that? So here, um, this doesn't guarantee that we are going to throw an error. Um, we're just simply returning no result. But I'm going to change that, as I explained, to throw an error, and then I'm going to show you how to handle it in the future video where we cover the error handling. Over here, this is supposed to be long in the controller. So going back to this, yeah, the error is gone, and it is it's good to listen to this suggestion and say, oh, replace optional presence condition with functional style expression. Let's do that. See what comes out of it. Okay, this is nice and tedious, I have to admit. We can leave it that way. Let's take the suggestion. Okay, so, but in our report, do we have a find by ID? Yes, we do. As I showed you, it was on our repo. It was in JPA repository interface. But we don't see the implementation of it. This is just an interface. The implementation is in the uh, dependency that we defined in our POM file. So anyhow, looks like this is ready to go. So let's compile and run it. Um, One thing I have to admit that I forgot to mention about is that we have to define how do we connect to a Postgres database. Spring needs to know that. Spring needs to know the data source um, information such as database name, username, password, uh, dialect, and things like that. Um, so in application.properties, we define those information. Basically, we say this is the JDBC URL and username, password, and we want to see the SQL. This is good for debugging. In production, we set this to false usually because it creates excessive logs. Um, some instances I have experienced servers running out of memory because of huge amount of logs that this create, and the debugging it was a nightmare. Anyway, so let's save this and go ahead and start this. Hopefully, I'm keeping my fingers crossed it starts without any issue. Yeah, it did actually. Now, in our database, we have an employee with the ID of 1. So let's go ahead and grab that. I can come here, I say localhost. Okay, we have that ready. Perfect. So we got John Doe and age 25 with ID of 1, but employee ID is null. Let's go ahead and find out what happened, why the employee ID is null. Hmm. So looking at our columns, you see this employee ID has a lower I in it. So that looks like what we define it as with an uppercase I. That must be a Postgres thing. Without looking at the table, we couldn't figure this out. So this is what an IDE is good for, looking at what we have in the database. How do we fix this? If you remember, I told you we can do this in our entity objects by specifying that this employee ID, if I find it, this employee ID, where is the employee ID? You're right up there. It has a different column. So let's say column name is actually all lowercase employee ID. Let's see if this fixes it. We restart this. Okay, let's try our luck again. Yes, we got back that employee. So how about we just insert another record and try it? Uh, let's try it. Just copy this and we change the values. This one from 1 to 3, we make it 1 to 4. And this John becomes Joe, and Doe becomes Henry. How about that? And this guy is a little older. Let's insert this one. Control, okay. Oh, see, we got a exception, unique constraint exception, because we are using the same ID. And we have specified that the ID is a primary key. Let's change the ID to 2 and execute this the same again. Looks like this time was successful. Okay, yes it was. Now Joe Henry is in our database and he is our employee. Congratulations, Joe, and welcome on board. How about we retrieve Joe from the database now? His employee was identified by number 2, and there we are. That's Joe, and we got the JSON back. So one thing at the end I wanted to point out is that if you notice, we didn't put any versions over here. And this is what we call auto configuration that Spring Boot takes care of. So what it does is that it automatically downloads the version that is appropriate and works with, or it is compatible, if I may say, with the Spring version that we are using. And it is best to leave the version alone because we could have an older version or a newer version specified that complicate things, and debugging it will become difficult. So if it is possible, let Spring take care of the versioning with auto configuration. Well, I thank you again for joining me over here. If you have noticed, we haven't done a few things so far. One of them is unit testing, which is very, very important. And we have to cover that. The other thing is that error handling, and we have to cover that as well. So these are basically the bread and butter of our programming, and we try to put them together in one more episode and then move on to more interesting stuff. We are going to build a GUI for this. We are going to save new employees, not using the console, but through the UI. So this all exciting things are coming up, and let's gear up for it. Thanks for hanging on with me, and see you in the next video.